All right, welcome everyone to the CIA question on flight performance. We're going to be looking at the flaps up takeoff ground roll chart, figure 1-3. Okay, so this question asks us to calculate the flaps up takeoff ground roll of an aircraft, and I got to 1,900 feet. That was my answer. I've already done the calculations, and let me run you through how I got to that answer. First off, we need to understand what is takeoff ground roll. Let's imagine a little runway. On the runway, we've got a pilot in his aircraft. He's going to start the takeoff. He adds power. The aircraft rolls down the runway at a rotation speed. He applies back pressure on the control column and the aircraft lifts off. Now that distance from starting the takeoff to lifting off is called the takeoff ground roll. It's merely the distance the aircraft rolls along the runway. A few things can affect the takeoff ground roll. All right, and those parameters are here at the bottom of the graph. The first one is outside air temperature. Okay, if it's very hot outside, the density would decrease, and that will, of course, create a longer takeoff roll. Weight. Right, if an aircraft is very heavy or the weight increases, it's going to also increase the takeoff ground roll. An A350, for example, that's very heavy, weighs a few hundred tons. It will actually use up much more runway than a Cessna 172. The last one here on the graph is going to be wind. A headwind will increase your, or a headwind will decrease your takeoff roll, and a tailwind, although not always recommended to take off with a tailwind, will increase your takeoff run. Right, firstly, the question asks, it gives us a temperature in ISA, plus 22, pressure altitude 3,500 feet, a weight of 2,500 pounds, zero wind. And I'd ask you, what is the ground roll? Now you can see in the Learn More section, there's a section explaining how we got to 30 degrees Celsius as our starting temperature. We've got to take that ISA temperature of plus 22 and use the pressure altitude that we've got at 3,500 feet and convert it to a temperature on the ground. And that's going to be 30 degrees Celsius. Have a look at the Learn More section to see how we got there. All right, now we're going to start with 30 degrees Celsius. That's the first parameter, and we're going to move up into the graph, upwards. All right, so draw a line upwards until you reach the pressure altitude line of 3,500 feet. All right, now 3,500 feet will lie between 3,000 feet and 4,000 feet, roughly halfway between the two. All right, so I draw a little reference line there for me, and I saw that we've got 3,500 feet, roughly halfway between 4,000 and 3,000 feet. Question, 3,000 and 4,000 feet. Now we've got to move to the right to the next reference line. And this reference line is going to be the weight reference line. All right, move across to the weight reference line until you reach 2,500 pounds. You can see 2,500 pounds here is the very start, and it's actually right on the weight reference line. So there's no need for us to move down to intersect the weight. We can simply just move across on the graph to the next reference line, which is going to be wind. All right, the question says there's zero wind. That means we don't have to, again, move down the reference lines or up the reference line, depending on tailwind or headwind, to calculate a wind component for this graph. We can simply just move across to the weight section. So we've got zero wind, and from the zero wind reference line, we move straight across, and I get about 1,890 feet, and that's very close to 1,900. Okay, so I'll go back to my question options, and I'll see, well, I'll have a look at the options they've given us, and the closest option I get is 1,900 feet. All right, 1,890 is very close to that. I'll select 1,900 and I'll take that as the right answer. And that's exactly the answer the CIA wants as well. All right, guys, thank you for watching.